Good morning all. In our last video we saw in unit 2 ordinary differential equation in calculus and its application. Today we are going to see unit 5 eigenvalue and eigenvectors. There is some shortcut of syllabus given here. In this unit we are going to see characteristic equation, eigenvalue and eigenvector, properties of eigenvalue and eigenvector, Cayley-Hamilton theorem, quadratic equation, diagonalization of matrix, nature of the form, reduction of quadratic form to canonical form by orthogonal transformation. In today's class, we are going to see characteristic equation and eigenvalue and eigenvector. Let's start the class. Here is the definition of matrix: a system of m by n element arranged in a rectangular arrangement along m rows and n columns and bounded by a bracket is an m by n matrix. Here m denoting the number of rows and n denoting the number of columns. So matrix is denoted in the form of A as A11, A12, etc. A1n. Here 1 denoting first row, first column, and in second thing A12, which means first row, second column, and so on. So up to AM1, AM2, etc. AMN. See the example given here: A equal to 2, 3, 5, 7, which is 2 by 2 matrix. Now let's see the definition of characteristic equation. Let capital A be the given matrix and lambda be a scalar matrix. The equation is determinant of modulus A minus lambda I equal to 0 is known as characteristic equation. So here A is our matrix, lambda is a scalar matrix. It is denoted as a formula by A minus lambda I equal to 0. Here I is a identity element. There is one more formula also. In this method we are applying the method 2 formula. See the problem using characteristic equation. Find the characteristic equation of the matrix 1, 2, 0, 2. Just write a given matrix as it is by denoting it as A. So given A equal to 1, 2, 0, 2. So the characteristic equation of A is, so this is the formula for 2 by 2 matrices to solve characteristic equation. So lambda square minus S1 lambda plus S2 equal to 0. Mark this as first equation. So in this we have to find the value of S1 and S2. So S1, for the value of S1, some of the main diagonal elements. So here the main diagonal element is 1 and 2. Sum means addition. So 1 plus 2, which equals 3. So here we found the value for S1. Next we have to find the value for S2. So S2 is nothing but modulus A. So that is the determinant A. So write the given matrix in determinant 1, 2, 0, 2. Now solve this 2 minus 0, which equals 2. Here we found the value for S2. Now substitute this S1 and S2 value in our given first equation. Hence the required characteristic equation is lambda square minus the value of S1 is 3. So 3 lambda 1 plus, and the value of S2 is 2 equal to 0. Hence the required characteristic equation is lambda square minus 3 lambda plus 2 equal to 0. So this is our first equation denoting the formula for 2 by 2 matrix, and also we will see the formula for 3 by 3 matrix. Here find the characteristic equation of the given matrix. Write the given matrix as it is in your solutions. So the characteristic equation of A is, this is the formula for 3 by 3 matrix. See here, lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. Mark this as first equation. In this we have to find the value of S1, S2 and S3. S1 we already know that the value of S1 is sum of the main diagonal element. This is same like in 2 by 2 matrix. So in this sum of the main diagonal elements, see the main diagonals given here is 2, 1, minus 4. Sum we have to add all the thing, and also there is minus sign in now element 4. So 2 plus 1 minus 4, 3 minus 4. So our answer is minus 1. Mark this as second equation. Here we have to find the value S2. S2 is nothing but sum of the minus of main diagonal element. We know the value of main diagonal element, which is nothing but 2, 1, minus 4. In this we have to take the minor value of this diagonal element. So the minor value of 2 is nothing but 1, 3, 2, minus 4, and although minor value of 1 is 2, 1, minus 5, minus 4, and the minor value of minus 4 is 2, minus 3, 3, 1. By solving this determinant, we get the value minus 4, minus 6, plus minus 5, plus 5, sorry, minus 8 plus 5, plus 2 plus 9, which is nothing but minus 10, plus minus 3, plus 11. By solving this, we get the value minus 10, minus 3, plus 11. So minus 13 plus 11 is minus 2. Hence we find the value of S2. Mark this as equation number 3. Next we have to find the value of S3, which is nothing but modulus A. So write the given matrix in modulus form. In 2 by 2 matrix for S2 we find the value for S2 in modulus A, but here we find the value of S3 in modulus A. By solving this determinant, we get the value 0. Mark this as fourth equation. So substitute S1, S2, S3, that is equation number 2, 3, 4 in first equation. See here, so lambda cube minus, there is minus in our formula, so minus the value of S1 is minus 1, plus next x2. S2 is nothing but minus 2 lambda minus S3. So the value of S3 is 0, just denote 0 here, equal to 0. By solving this, we get lambda cube plus lambda square minus 2 lambda equal to 0. This is how we find the value of characteristic equation. Next we will see the definition for eigenvalue and eigenvector, and also there are 4 types in this eigenvalue to find eigenvalue and eigenvector. Let's see type 1 in this class. See the definition of eigenvalue. Let capital A be the given matrix. The roots of the characteristic equation are called eigenvalue. So we know the formula here, right? So using synthetic division, we will find this method. So this is our characteristic equation formula. Using this, we will put the root and using synthetic division method, then we will find the roots, which is eigenvalue. Next, eigenvector. Let capital A be the given matrix and lambda be the scalar matrix. Then the column matrix x equal x1, x2, etc. xm, which satisfies A minus lambda I into x equal to 0. So this is important. See, the formula for eigenvector is A minus lambda I into x equal to 0. We know that A is a given matrix, lambda is a scalar matrix, I is our identity element x1. If it is 2 by 2 matrix, we denote x1, x2. If it is 3 by 3 matrix, x1, x2, x3. Let's see the problem. Okay, before that there is 4 types in eigenvector. So first is non-symmetric and non-repeated eigenvalue, which means symmetric meaning square matrix is equal to its transpose. See our first matrix 1, 7, 3 row. See the column 1, 2, 1. So which is not equal. So we can say that non-symmetric and non-repeated eigenvalue. See the eigenvalue for the matrix is 1, minus 1, minus 2. All the eigenvalues are different. So this is our type 1 non-symmetric and non-repeated eigenvalue. See the type 2 non-symmetric and repeated eigenvalue. Non-symmetric same and repeated eigenvalue means see in our 1 comma 1 comma 4. This is our eigenvalue. In this 1 is repeated twice. So this is our type 2. Next type 3 symmetric and non-repeated eigenvalue. Symmetric meanings square matrix is equal to its transpose. See in our square matrix our row is equal to its column. So that is transpose. See 1, 3, 5 in our row, and also see the column 1, 3, 5. So this is symmetric and non-repeated eigenvalue. For if we solve this, we get the different eigenvalues. So this is our type 3. Then our type 4 is symmetric and repeated eigenvalue. Symmetric row equal to its column, and also repeated eigenvalue. In our eigenvalue 1 or 2 is repeated. So this is our 4 types. Now in this class we will see type 1. So based problem based on non-symmetric and non-repeated eigenvalue. So here I given working rule for the type 1. So step 1 is we have to find the value of characteristic equation. We already know the formula, which is lambda square minus lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. This is applicable for 3 by 3 matrix. Step 2, we have to find the value for eigenvalue. In the definition itself, we know that eigenvalue is we have to find eigenvalue, which means using synthetic division we will find the roots, which is eigenvalue. Next we have to find the eigenvector using the formula a minus lambda I into x equal to 0. Then we will form the equation. Then by using cross rule multiplication we find the value of each cases. Next, and now see the problems based on non-symmetric and non-repeated eigenvalues. To find the eigenvalue and eigenvector of the matrix, so there is a matrix given. So note that our rows and column are not equal. So simply we can say that it is non-symmetric. Next we will find eigenvalue. Then we will decide this is a non-repeated eigenvalues. So just write the given equation as it is in your solution. So given matrix, step 1 we have to find the characteristic equation. Step 2 we have to find eigenvalue. Step 3 we have to find eigenvector. Now let's solve step 1. Characteristic equation of A is, this is 3 by 3 matrix. So formula for 3 by 3 matrix is lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. Mark this as first equation. In this we have to find the value of s1, s2 and s3. We know that s1 equal to sum of the main diagonal element. Here the main diagonals are 11, minus 2, minus 6. By solving this we get the value for s1 equal to 3. Mark this as second equation. S2 equal to sum of the minus of main diagonal element. So write the minus for the diagonal element. We get the value minus 8 plus 4 plus 6, which is 10 minus 8 equals to 2. Hence S2 equal to 2. Mark this as third equation. Next we have to find the value of S3, which is modulus A. So write the given equation in modulus form. By solving this we get the value as 0. Hence we find the value for S1, S2, S3. So that is equation number 2, 3, 4. Just substitute these three equations in our equation number 1. So we get the value lambda cube minus 3 lambda square plus 2 lambda equal to 0. So mark this as fifth equation. Hence we find the value of characteristic equation. Next in our step 2 we have to find the value of eigenvalue. Put lambda equal to 1 in equation 5. Why we are taking this means we have to get the value of our left hand side and right hand side, which is equal to 0. If it is correct, then our root is lambda equal to 1. If it is not correct, then we will move on to lambda equal to 2, lambda equal to 3, lambda equal to minus 1, minus 2, minus 3, 0. So we can put any types of value, but we have to get the value of our left hand side and right hand side must be 0. Here by putting lambda equal to 1 in our equation 5, so it will become 1 cube minus 3 into 1 square plus 2 into 1 equal to 0. So 1 minus 3 plus 2 equal to 0, 3 minus 3 equal to 0, 0 equal to 0. So in this left hand side and right hand side is equal. So I am taking lambda equal to 1 as my first eigenvalue. Therefore the root is lambda equal to 1 by using synthetic division 1. So in our characteristic equation, write the coefficients in our synthetic division. So see, lambda cube coefficient is 1, lambda square coefficient